So today we're going to be going over rational functions with slant asymptotes. So we've talked about when the horizontal is at 0, when the horizontal is at the coefficient of the top and the bottom. But now we're going to be talking about when we have no horizontal, but we actually have a slant asymptote. Not much changes in the grand scheme of things. Okay? So when we're looking at our rational functions, we're still going to be using the top, bottom, both 0 to find all our information. Okay? Nothing's changed there. So of course the top gives us our x-intercepts. So our x-intercepts are at 4, 0, and negative 5, 0. Okay, so the top setting equals 0 gives us our x-intercepts. The bottom gives us our vertical asymptote. We have 1 at negative 2. Okay, our horizontal asymptote comes from both the top and the bottom. If we FOIL this out, get this, x squared plus x minus 20 over x plus 2. Okay, now you can see that the top power is bigger than the bottom. And this brings us to our third case of rational functions when the numerator is a higher degree than the bottom. That means that you're going to have either a slant or an oblique asymptote. Okay? And in this case, since it's just one power bigger, we're going to be dealing with a slant asymptote, which means we have no horizontal asymptote, it's a slant. Now, the only thing that we're going to be doing different here is that we're going to have to do long division to find that slant. And we'll do that in a second. But that also leads me to my y-intercept. Now, normally, you just plug in 0 to find your y-intercept. So f of 0, and it would be negative 4 times positive 5 over 2, which is negative 20 over 2, which is negative 10. But since I have it in this form over here, with it in polynomial form and not in factored form, if you plug in 0, you can see that these x's all become 0 and it leaves you with negative 20 over 2. That's kind of a shortcut when you have it in that form. The number on top and the number on the bottom, if you put them over each other, you basically get to here, and you can see that your y-intercept is 0 and then negative 10. So it's just a little shortcut if you have it in that form. And since we have to have it like that anyway to do our long division, it's nice to see that we can use that to find our y-intercepts a little easier. So now we got to find that slant asymptote. So we got to do long division. So we set it up with the x plus 2, and underneath you put your x squared plus x minus 20. Okay, and now we do our long division. So again, what times x gives me x squared, and that's x. So you get x plus 2x, that's x squared. Subtract and change the signs. So you get x minus 2x, which is negative x minus 20. Bringing that term down. And then what times x gives us negative x? That's negative 1. And at this point, we can stop. Okay, because once we go further, we're going to get a remainder. But when we do this, we don't care about the remainder. Whatever we end up with here, that is the equation for our slant asymptote. So the equation for our slant asymptote is y equals x minus 1. Okay, so basically the long division, whatever we get up at the top without the remainder, that's our slant asymptote. Okay, so that's basically the only difference between what we've been doing so far and a function that has slant asymptotes. Because next we're just going to plot all of our information like we've been doing. Okay, so our vertical asymptote is at negative 2. Now, our slant asymptote is in the equation of a line, slope-intercept form. So our slope is 1 over 1, and our y-intercept is negative 1. So basically, you start with your y-intercept and use the slope. 1, 1, up 1 over 1, up 1 over 1, up 1 over 1. And we'll use that slope to graph our slant asymptote. And that's what it looks like. Okay. And then we plot our y-intercepts at negative 5, positive 4, our y-intercept at 0, negative 10. Okay, so now we've got all the information graphed. And again, the only difference between this and our other cases is that we're dealing with long division to find that slant asymptote. It's not a horizontal line anymore, it's a slant line. Okay, all other applications rules apply. So we have one vertical asymptote, which means we're going to graph two different pieces. Okay, now that means we're going to have one piece on the left and one piece on the right. So think of it just the way we used to do it with the horizontal asymptotes. If we look on the left, there are two cases. The first case, when it comes down the asymptote this way and follows the slant like that, or it comes up the asymptote there and follows the slant like that. Those are our two possible cases. Okay. Now, obviously, it can't be the bottom one because we have this x-intercept sitting here at negative 5, so it has to cross the x-axis, which means that we have to use case number 1, where it comes down from the top so that it can cross that x-intercept. Okay, so you can do it two ways. You can either start at the x-intercept here and just go up and follow there, and then come down here and follow it like that, or you can just start drawing it from the top. But it's easier since you have that point to start the point and just follow the asymptotes. Now, the same thing on the other side. It either comes up like this from the bottom, like that, or it comes down like this from the top. And the same thing, we're using the information we have. Since we have that y-intercept and the x-intercept at 4, we know it has to go from the bottom. And again, you could just start at these 2 points, connect each other, and like I said, just follow the asymptotes. There you go. Now, the number one mistake my students make is treating the slant asymptote as a vertical asymptote and add in pieces. So they would say, okay, well, this is a vertical asymptote here at negative 2, and this slant means that I'm going to have 3 pieces or 4 pieces. And I see them do this all the time where they'll actually put in both pieces. But what's wrong with this when I draw it like that? Well, we're dealing with functions. And functions have to pass that vertical test, right? The uniqueness theorem, that every x only has one y value associated with it. And since this would be above it, it wouldn't pass that vertical line test. So you need to be careful. When you're done, you need to make sure that your answers make sense. Okay, check yourself. So that is our rational function. Okay, so let's try another one. All right. So again, I got this rational function. Start by finding our information. Set the numerator equal to 0 to find my x-intercepts. So I have one at 0, 0, and one at negative 7, 0. And since I have an x-intercept at 0, 0, I know automatically my y-intercept is at 0, 0. Okay, so I don't even have to plug in 0 in this one because my x-intercept, since I have one at the origin, it's both my x and my y-intercept. My vertical asymptotes come from the denominator, so solution x equals 5. And then we look at both the power of the top and the bottom, and you can see the numerator is 1 power greater than the bottom, which means we have this slant asymptote. So I FOIL this out, 2x squared plus 14x over x minus 5, so that I can set up my long division. So I just distributed the 2x in. So I get x minus 5. This is 2x squared plus 14x plus 0. And remember to add in that 0 because that third term is missing. And we do our long division. So here we go. What times x will give me 2x squared? 2x. So we get 2x squared minus 10x. Subtract, which changes the signs. So we get 0, and we get 24x plus 0. And what times x gives me 24x? 24. And I'm done. That is my slant asymptote. So we have a slant asymptote, and the equation is y equals 2x plus 24. Now, that means that our y-intercept on that asymptote, our slant asymptote, is going to be at 24. So we'll do some work in a minute just to make sure that it fits on our graph. So we have a vertical asymptote at 5. So let's graph that at 5. Well, actually, let's wait, because we're going to need to rescale our graph so that it'll fit. And you'll see what I'm talking about in a minute. Okay, so basically I'm going to change my scale from 1s to 5s. Okay, so this is going to be 10, 20, 30, 40, 50. 10, 20, 30, 40, 50, like that. Okay, so here we go. So our vertical asymptote is at 5, which is going to be right here, because each one of these dots are 5s. And then our slant asymptote has a y-intercept of 24, which is right here, and then a slope of 2. So it's going to look something like this. Okay, we have a y-intercept here at 0, 0, and another one at -7, which is going to end up right there. Okay, so there's all my information. So let's talk about it. We're split up into 2 pieces here. Okay, so let's look at the right side first, because that's going to be the easiest one. So when we look at this right side, we have 2 possible solutions. One, it's either going to come down like this and come out like that, or it's going to come up like this and follow it that way. Now, like I've always said, what's not there is just as important as what is there. And notice that for this second part, there's no x-intercept right here. So since it can't cross the x-axis there, we know it has to be the one on top. Okay? So we know it's up there. It's because there's no x-intercept. Now down here, I have an idea what it's going to do, but again, since I have these 2 points, I don't know if it connects like this or if it connects like that. So the only way to find out is to make sure by plugging in a point and finding out what's happening there. So I can plug in any point between 0 and -7. So I'm going to keep it simple and plug in -1 to see if I'm on top, on the positive side, or on the negative side there. And when I plug it into its factored form over here, when I plug -1 in, I'm going to get -2. So it's a negative on top. When I plug -1 in here, I'm going to get +6. When I plug in the bottom, I get -6. So I get a negative divided by a negative, which is positive. So I'm on the positive side here at -1. Which means the only option I have is to come up here, cross here, come back down, and then follow my asymptote out like that. Again, if it did the top part, if it came down this way and followed this asymptote out, my x-intercept would have to be way out here, and then it wouldn't hit the other x-intercept anyway. So just remember, when you're doing these, you really have to think about what it is that we're doing. Look at the different cases and see which one is the most accurate.